Okay, so let's start now. Well, first of all, well, thank you for joining this webinar. It's always a pleasure to see the interest of IPSDK, of our work. It's always also interesting and very inspiring also for our R&D department and R&D developers to see that, well, what they are developing is always interesting for you, you in terms of users. So, well, we can see that there is always great interest in our new features, version after version, year after year. Well, due to the pandemic, it's not event after event because most of the events are now being canceled or being online. But for a short future, we will be able to present you in a live mode all these new features. Most of the developments that I will present you today were realized in partnership with IPSDK users. So those evolutions now are integrated within the product, within the official release that I will present you. This permit to enrich the library and IPSDK with new features. That's very important also because some of the enhancements that I will provide you today are also based on your feedbacks. So feedback are very important for us because we are using IPSDK in our internal mode, but you are using it in your daily work. And that's very important to be sure that, well, if we can remove one click, it's very important to know that. Well, so since the pandemic started, we are quite used with all this remote and Zoom, Skype, WebEx, whatever the tool, all these sessions. But during this webinar, all your microphones are muted just to avoid some parasite noises. The chat is open, so feel free to ask any question during the presentation. I am not promising that I will answer your questions during this presentation, but I will try to have a look time to time to this section, sorry. So if you have any question, really feel free. Otherwise, we will have some free minutes, some minutes at the end of the presentation. I will try also to remain within, let's say, between 50 minutes and 1 hour. Well, the idea is not to be too long, but in the same time to present you relevant information. Even though you already know us, so just a small reminder, we are Reactive IP. We develop one main product, which is IPSDK, that can be presented with or without graphical user interface. So without graphical interface, it's a library, a technology brick that then you can combine and that you can use inside your own tool or to distribute features. Or with graphical user interface, IPSDK Explorer, which is a tool that I will mainly focus on today because it's much easier to present you new features with some tools, not only code lines. As you already know, we also support our customers and we support you with trainings, with some specific developments. So training can be generic or can be very focused, very customized trainings. We also can support you with developing new features, either inside the product, which will enrich the library or the core product, or by developing some workflows, some scripts on top of the library. And in some cases, it's not the most significant part, but in some cases, we can also get some customers requesting some outsourcing. They don't want to be using the software, but just to get some result of analysis. The timeline that you already know also, but just I guess it's important to perceive how much work were done in so few years. So 9 years ago, it was the foundation of the company. 7 years ago, first version of the library. So image processing library available in Python and in C++, Windows and Linux. And 4 years after, there was the first version of the product with a graphical user interface. So tool that you already know with so graphical user interface in open source. So you can completely use it. You can also get inspired by it if you need to integrate or if you need to develop some elements. You can also tune it. And what is very nice for persons that are not comfortable with Python scripting, as you already know, there is this Python script generator which permits you to develop Python scripts without writing a single code line. End of 2020, machine learning. So two main machine learning modules. One that is solving a bottleneck, which is a segmentation, starting from raw data. You want to segment it. That's most of the time the most tricky part. But it's not the final part. There is always, after this segmentation with machine learning, you still need to smooth your data set. You need to filter, to make some morphology, to make some comparison, whatever. And that's where the smart classification appears. And it's very, very useful to finalize your analysis. And so 2022, the new version, the new feature that I will just show you. So the main point that we will check today will be enhancement in the graphical user interface, new features and new enhancements in the machine learning. So today I will mainly focus in the smart segmentation, but of course there is some very similar enhancements in the smart classification. A new thing which is multi-channel spectral energy, depending on the acquisition device. It's not exactly the same wording, but it's now we can handle that. Some new features in the processing, in measures and analysis, and also an interesting point in the Python scripting. So let's go. So this webinar will be presented as a live, let's call it live demonstration. So mainly, most of it will be within the graphical user interface, so that you can visualize elements. So this Tortuosity part, we will show you that later. So first of all, let's say it's not a bug fix, it's more like an enhancement, graphical and ergonomic enhancement. This is a 3D data set. And previously, when you wanted to make a crop, we were just cropping half of the Z slices, half of the data set, and not cropping all along the full 3D volume. Well, it was done for many reasons, to minimize memory, just to go on region of interest, but most of you dealing with 3D datasets were requesting to be able to make an extraction along the full dataset. And so if we have a look here, we have 99 slices. If now I make a crop, you will see that we can still get our 99 classes. Propagation of this region of interest that you just display on a 2D dataset will be performed along the full slices. So that's more a way, that's why feedbacks are very important. It's just we want to adapt IPSDK to your way of using. Other point that we can do now for those who are dealing with Zeiss devices, now we can directly integrate and import CZI files. So the Zeiss format, we can also deal with multi-JPEG files, so new readers that we can ease a lot of time and a lot of importing data. Other things still in 3D. Previously, when you had a 3D dataset, so you could import datasets with multi-slices. So you could open one slice, one image, one 2D image was one slice, and we could import that. But when we wanted to save the 3D dataset, it was only saved in one file with all the slices inside. Now it's possible. Save all the images as multi-slices. And in that case, you will get, so in that case, we will get 99 2D images. So that may be of interest to be able to do that. Other additional thing, when you make process, automatically, which was not the case, but now automatically, every time you want to get a result, you will visualize the result and not remain just showing the input, but you will get directly to the output. What is interesting is to get the result of a process. So that was also, so it's fewer ergonomic, but it was quite interesting. Still in the graphical user interface and in the daily usage, previously, when you wanted to work with a display context, let's say that you wanted to go displaying from 50 to 150, you needed to go to apply in this sticker icon. Now we can directly use it just with the entry button in your keyboard. So that's still removing some useless clicks, let's say. What we can also do, let me just open a dataset. So you also may know this retouching bar, where you can merge some datasets, some particles. You can split some particles. You can also have the possibility to remove elements. You have the possibility to add some new objects. Now there is a new, so you also have the undo button. You can define how many undos you want to save, but now there is a new icon, which is that just to remain some specific particles. Instead of removing all of them, just to remain only one or two, you can just tag the ones that you want to save and to keep. Other thing that we have, let me just show you here. So you can get an image, and you can put in this image an overlay. You can play with a display, and you could also imagine, let's say I want to change my display context. Okay, but this is still the same image. Nothing has been grabbed, and it was complex to save it. Now we have this new icon, which is roughly a copy paste of your display. So if we were looking at this image with my overlay, you can see here and below, you can see that you have some value, which is the gray level of the grains image. You can see overlay 112, which represents the ID of the label. And you can play with the opacity and the transparency of the display. Now, if we go here, you can see that now we have a RGB image, which is just roughly a copy paste of what are already existing, which one we can save and so on. So that's really very interesting when you have found the right settings about visualization. What can we do also in terms of visualizing things? In some cases, when you want to go to production or with persons that may be frightened with all these chapters on the right panel, what could be interesting would be to be able to use Python scripts without showing all the features. So now we have created some macro interface in which you can call some parameters, some settings. So in that case, I will just call a folder. It will be for fiber analysis. I can design, where is my fiber? Okay, here it is. You can define some elements and get your analysis processed. In that case, no need to go and to search for the entry in the right chapter, and you can get directly your results. So there it is. You can visualize things. You can also add, and that was not really possible inside the, let's say, the traditional graphical user interface of IPSDK Explorer. Now you can also add some functions, and you can, and in that case, it was demanded to give some histograms, some specific histograms, unitary, cumulative, and so on, and still get the values of each element. So that's really a very nice feature, which permits really to be able to use macros, to use the scripts without having all this full list of features, which is very interesting when you are prototyping. But if you are speaking and imagining about production line, it may be complex. Okay. Another point that we integrated. Let me show you that. So this is a result of a 3D of the 3D dataset. And it could be interesting to have a very, how to say, a shape visualization, a very basic visualization, just to be sure that our object in 3D is really accurate with what we're expecting. So starting from a label image, you can get a file that then you can save in STL and export it. So that's another way. We are not speaking about a movie maker. We are not speaking about a lot of things, but just to get a raw visualization could be very interesting. Okay. So that's it for the main, let's call enhancement or new features inside the graphical user interface. Let's go now for the smart segmentation. So if we go with a smart segmentation, here is an example. What you can do is, let's go here, existing model. Let me just clean a little. Okay, so now what we have here, so new things since the first release of the machine learning module. Now you can get here a display context. So you can change the display context, say, okay, so you can, as in the main panel of IPSDK, you can change the display context. You can also go back, okay, you can define your classes, but you can also call previous settings that you may have already created. In that case, it will recall the full number of classes, their color, and then you can just apply them. We also integrated new features, which are possibility to select pixels, defining a region of interest, defining some polygons. We also integrated an undo button, which was quite frustrating when you made a, let's say, bad click, and you had just to go with a rubber and call it back. So now we can do that. We can also, so you still have the list of features, a list of the percentage of usage. Previously, we could only, so let's say, optimize with removing the less interesting features. It was only with integers. Now we can define that we want to remove something less than 0.1, and it will be recomputed. You can also, within the graphical user interface, here, you can also say that you want just to display only maybe the internal face, or just want to display the one that you want. So it can be interesting just when you want to have some very nice precision on the elements. Okay, so it's not, I cannot display it, but we also increase the speed of computation during the prototyping phase. So previously, the generation of the model, the prototyping model, was not parallelized. So now everything is parallelized much faster than what it used to be. When you have some small region of interest, you will not see a main difference, but if you have some quite big region of interest in the prototyping, you can see all this feature. Other thing that is quite interesting is we integrated a probability mask. Probability mask means, well, you can see, so it's going from 0 to 1 or 0 to 100%. And everything that is in green, you can get here the information, value is 100%. Means that we are sure, there is no doubt that this pixel must be classified in one of the classes. And when you are close to the red, you will see here that we are 41%. Most of the times, the main doubt will be at the edges, but how is it classified? So in that case, you can see that we have 4 classes: background, layer, internal, and interlayer. And so by default, each pixel could be as 25% of chance to be in any one of the classes. So the bigger you are versus the 25%, the more accurate will be your classification. But it can be very interesting for you to really focus on the pixels where there may be some tuning or maybe some advanced inspection. Okay, so now we can call in the machine learning, we can call either the smart segmentation and get the values. You can also now call, if you want to display the probability mask. Oh, sorry. No, okay, it's not a good model. Okay, here it is. So I can also export the result with a probability mask. I can just change a little. Probability, yeah, okay. And you can get exactly the same data set. Other thing that is interesting, you can define also the memory ratio. Memory ratio, what does it mean? By default, well, I just have one of my slides. Let me show you that. As you may know, IPSDK, well, in any machine learning feature, what you will see is you have an input data, you get an output data, and in the middle, you get a lot of features, a lot of intermediate features that are computed. And of course, you will have to deal all that into memory. If you have two big data sets size versus your memory, it may just crash. So what is doing IPSDK is IPSDK will check the maximum capability of your machine. And if it can handle everything from in full resolution, in full dataset size, okay, it will do. But if it's not possible, IPSDK will automatically compute the best or the maximum sub-volume to be handled, and then it will reconstruct little by little your output. So in that case, as you will just be working on region of interest, you will limit the dataset, the full dataset amount that you will be managing at one moment. And of course, you will still continue, each feature will be computed using the capabilities and the speed capabilities of IPSDK. So you can also do that. So what is doing, the IPSDK will check in the hardware configuration and will define the best configuration, or at least the full capabilities of your machine. But it may arrive that you are sharing your machine, your workstation, with other software, or with maybe on a server where you could have, I don't know, 2, 3, 4, 5 persons working on the same server at the same time. So it means in any case that you will not get the full capability of your machine. So you can define to say, well, I just want to use only 50% or 30% of my memory, of my full capabilities of the machine. So in that case, you will not get, even though IPSDK will be able to work on sub-volumes, you will not crash your machine because it's really depending on how many usage how many capabilities are available, are free for the computation. Last point, still on the machine learning. If you want to make a label analysis to get some measurements, you will not now get, so you can define, you already know, you can define the columns and the values that you want to analyze, but now you will get also the names that you integrated inside your machine learning. You will not get only ID1, ID2, ID3, you will get the name that you defined previously in the machine learning part. Okay, so that's it for the machine learning. Now, new feature. So I will focus on an optical microscopy image, but multi-channel. Of course, it could be multispectral, it could be multi-energy. But what does it mean? As I said previously, it means that data set with different acquisition combined all together and all, let's say, merged with different channels. So if you still have a look here in the value, you will see several information. So XY position of the pointer, but you can see here 4 values. What does it mean? It means that this image, even though it's a RGB image displayed, has 4 channels information. So 4 channel information means that you have more information than only the one displayed. So what we can do is we can extract now some channels. So that's very new information we can define going from, so 4 channels, so it means that channels go from 0, 1, 2, and 3. So you can extract channel 0, you can extract channel 1, and so on. Channel 1, channel 2. And you can see like this, the different channels, and we could also extract the 2 other ones. So that's really very interesting, and you can also create from several channels you can now create a multi-channel image. So just using highlighting the images, you can combine them. In that case, I just add 2 images. I can get only 2 channels. We can also define which are the channels that we want to display. So by default, the operating systems only permit us to display 3 channels, but you can define which one you want to attach to the red, the green, or the blue channel. So we can say, for instance, that we want to add channel 3, here maybe channel 2. So you can completely change it, or you may even say, I don't want to have red information, so I want to add no information concerning this channel. Okay. What we can do also then is in the machine learning, of course, if we go on the model with machine learning, so let's go here. You can say, so I'll just clean a little. You can see here in the list of features that for every feature that will be computed, you will get all the information. So all the channels are computed. So we don't only assume and handle only the 3 channels displayed, we really assume and manage all the channels available. So the more channels you will have, the more robust, the more precise will be the model. And then, of course, you can then just call your model and get your result of the segmentation. As we are still here, we can also, let me do analysis. If we want to make a measurement and we want to have information also on the different channels, we can just take the latest image. So the row, let's call it the row information in my features, my column that I want to compute. I just added some information about the intensity. I linked my label image with my original image. And now I will get information, and you will get a mean value for each channel. So it's it's available in the segmentation, available in the computation, available in everywhere. So it's a full management of this multi-channel information. So that's it for the multi-channel information. So we also added some, in the processing part, some, let's call them quite frustrating element. Where is my element? So when we have, so as you know, when you go with your mouse along across the image, you can get all the information, X, Y, and so on. And sometimes it would be interesting to get some pixel values, pixel information for seeds or for whatever you may need. So now we integrated a new feature called locate pixels. So as you may have seen, we also have the same with locate voxels if you are working in 3D. And now you can get a table with all the positions of your points. So very interesting. Then if you need to use them, maybe, well, once again, for seeds, for watershed, or for whatever. Other thing that we added, possibility to create some label images from binary images. So let's go here. So let's imagine you have an image, you created a gradient because you would like to perform a watershed with markers. You know that there are some light, some gray, and some black areas. So what you can do is convert one of these planes, of these binary images, in a label image, label 16. So let's go for the light, for instance. And you will create a label image with only one information. And then you can use this add marker feature where you can just add, let's say, the gray, and you will add a new label value, which will be label 2 here. I want to overwrite my original image, so I'll just type image 9. And now you integrated and you created this label using information from 2 binary image. Now I will do the same thing, adding value 3. And now I have created a label image based on my binary image. And this result can be used now to make a watershed seeded. So in that case, it's done in 2D, but it could be the same thing in the 3D based on the gradient. And you will get automatically, let me just show you in overlay, and you will get the result of the watershed based on your seeds, where you could create your own label. Of course, this was already possible, but with a lot of coding and a lot of mathematics to multiply your binary and so on. So that's really, well, once again, it's to ease the usage of the library. Another tool that was already existing in IPSDK, but which was very complex to use, was the Tophat. So Tophat, what is a Tophat? For those who are not familiar, so the idea of Tophat is, oh, it's not the right particle, sorry, where is my Tophat? So Tophat is, the fact is you are looking for local peaks or local valleys, and then you will play with a radius just to define some elements. So that's very interesting when you want to detect some particle, let's say gray on gray. In that case, if you have such an image, if you want to use a threshold, a traditional threshold, so you can do that, but if you want to get only the, let's say, the dark particles, you will soon see that this gray shape will have a real issue. So traditional threshold is not the right tool. So using this Tophat and using this fact that we are looking for local maximas or minimas, depending on what we're looking, dark or light. In that case, if we are looking for dark particles, you can play very easily using the threshold to define the elements. It was complex because we had to know everything about the mathematics behind, but now since it's interactive, you can completely play with the values that you want, and you can see that we can achieve very nice results directly on that. So here it is, image 9. So that's about the Tophat. Other point that we integrated, let me check my data. So let's assume that you have that type of images and you would like to get the peak, the crest line here of the information, so which is the interface between two materials. And well, we have a nice orientation. What we can do, so is just make a gradient where we can get those information in X and Y. Just to ease the analysis, I will put everything in absolute value to get only positive values. And now we have this new ridgeline 2D, which can be used directly. You define, so we are looking for a light peak. You can define it's going from from left to right or right to left, so depending, direct or reverse, which is a propagation axis. If you have several layers, you may also add some masks just to define the region where you want to process your analysis. And you can get, so let me go here, image 12 in overlay. So you can get this line, and you can get the list of the pixels that were computed during this ridgeline operation. So that can be very interesting to define some propagation or to define some interlayers elements. Still remaining roughly in this area, we can also go with the tortuosity. So let's go with this data set. So I will just make a mask and define what I want to compute. Okay, dark particles. Now, if I want to define the tortuosity through this data set, we have tortuosity, which is available in 2D or in 3D. So in that case, I will just display for the webinar in 2D. You can still define direction, X, Y. direct or reverse, once again, left to right or right to left. And then you can just compute it. You will get the lens that has been computed and the tortuosity that is computed. So then you can do that also along the y-axis, and you will get exactly the same type of elements. So this is, so far, it's still a script, so there is no direct documentation, but well, feel free to come to us and to ask if you have any question on that. And one main important feature, and you may have seen that in our I'd say on LinkedIn, and we also integrated that in our so here it is, for instance. So we have an article on that, which is a watershed and the adaptive watershed. So what does it stand for? When you have particle like this, so you know the watershed, and watershed works pretty well as long as you have some spherical particles, and as long as you have all the particles roughly with the same size. So you can, I will do that directly in label just to be more visual, but if we apply on the separation part watershed, I can get very nice results. So here in that case, I can remain this U shape, I can get this big particle, but if we have a look a little more in details, this is not cut, this is not cut, and this one is not cut. So we can play with it. Let's say, okay, I will want to reduce the dilation factor, and then we can see that here it's starting to be cut and separated, but here the U shape, well, we lose some information. But if we want to go one step further and to separate also these objects, we can see that, well, here it's better, but here in that case, we don't have any U shape. We have a bunch of particles, which is a problem. Why is it doing like this? Its watershed is based on the distance map, and it assumes that all the particles will be, so you get a setting, and all the particles will be using the same setting. So you have this maximum, and if you apply here a radius here, you will use the same for the small particles. So that's why you will have a main problem, and you will have to accept some problems. What we integrated in IPSDK is, I just remove this distance map. It's just to say, okay, I have my distance map. Why not take in account each maximum and make a computation and the separation around a certain percentage of value of this distance map? So what we will do is here, if I go on this adaptive watershed, you will define a percentage of this distance map. So let's go on, for instance, put it in label just to be more visual, and you can see 0.5 maybe. Oh, it was too big, so okay, 0.6. So you can see that you can remain the U shape, you can cut the particles, and you can get this big particle not cut, extra separated. So that's, I will not go too deep in details in this algorithm, because we could make a full webinar on this element. But as I said, you can, we have a presentation and we have a paper on LinkedIn. There will be some communications. But that's the idea, really. Instead of applying the same parameter for every particle, just apply a percentage of particle, and you will use mainly the seeds, which we can, every particle will have a relative value to be to cut the elements. Okay, let's continue. So we are reaching the maximum time that I wanted to allocate and to go on that. So we also added one main new feature, which is a macro. Let me show you the batch processing, sorry. So let's assume that we have this type of images. We can make segmentation. So I will go not through segmentation, so automatic one. I can get a result, great. But if I have a lot of images to compute, I will have to redo that image per image, or I will have to go in a scripting to make some loops and so on. Now we have this new icon here that is available on every algorithm, available also on every script. And you can just define your input folder where it will be created a result folder, and you can just compute it. And all the images that are present inside, here are the results, all the images that are present in the input folder will be automatically computed. So it can be very fast. You can get here all your results. If we want to go one step further, we can also imagine doing that with I would say a more advanced script, not only doing a simple threshold, but we could say something like that. Where are my images? Okay, here it is. So we could imagine doing something like this. I want to compute, I want to get a label, and I want to get some measurements. So I will clean a little also so that it's more visual for everyone. So let me just restart my computation. And so I can get here my result. And as you know, connection between image and the spreadsheet. Now, if I want to replay my scenario again and again on all the images, I'll just remove everything. Can just restart with my same element. It will be written in my result folder. I can also merge my results if I want. So merging means that you will get one result per image, one spreadsheet per image, but you can also combine all the results in the same spreadsheet. So it's being computed. Folder is on my second screen. Okay, let's remove it. So you can get here an Excel file. So you can get on which, so you have all these elements, all the results, on which image it was computed. One, a lot of particles, 2, 3, 4, and so on. But you can also get your images, the results here. Here they are. Okay, and you can also load your analysis. Or it's opening on my second screen. Okay. So if we go here, you can see them. Here they are, second one, and so on. What you can do also now is you can merge your analysis and create a multi-analysis folder. Here it is. And you can see that you will get the values that were computed, and you also have the name of the image. So that's another way of merging all your results. And of course, you can get all the statistics. And if you want to get some histogram, you can display not only a one image histogram, but a full analysis histogram. So that's it for the batch processing. Okay, let me just save a little memory. Last point that can be very interesting is when you are developing scripts, you may be using a script and you want to maybe develop some little scripts, and you would like to encapsulate all of them in one single big script, like a meta script or whatever. So what we can do, so let's imagine this type of image. So you can, of course, call it and say, let's say, well, in that case, SCM grain, okay. So I can call, it was not the right one. Okay, SCM smart segmentation. Okay, so you could imagine doing some threshold just to get only the grain. So let's say only value 1. Okay, and then continue with your script with labeling and so on. So I already created a previous script, which is called same grain smart segmentation. So if I go on the grain image, okay, so you get the same result, and then we could like to continue. What we can do now is use this macro, well, this script. Okay, so you will see. And if we have a look a little more in detail, you will see that we can have all the script, but first we will call a script that has been already developed, the SCM grain smart segmentation, the one that I used previously. And then we continue with all the aspects. So it means that you can really encapsulate scripts inside bigger scripts. So that's very new inside IPSDK and can be useful when you want to reuse some scripts as technology brick. Well, that's it for the main evolutions of IPSDK. Last point that I may mention, as we are being, well, as you have seen, well, the product is evolving a lot, and we try to also communicate and try to find the right channels to communicate with you. So you can follow us on our website, but on LinkedIn, we're also very active on LinkedIn. We try to communicate, so a lot of LinkedIn. So we also have an IPSDK community group where we want to also to provide information. We have some YouTube, so we have a lot of features that we communicate through small tutorials, roughly less than 2-3 minutes. And we have now a Twitter account, so it's very new, only maybe 1 month old. And so we will continue communicating. So please follow us on that, so you'll get the latest information. And really, it's important, as you have seen, most of the features were coming back from the community, coming back from the users. So it's very important for us to get your feedbacks.